Okay, thanks everyone again, for zooming in. And I know it's a really, really busy time at the end of the year, and that you take the time for attending the seminar. So Michel, can you please the next slide? So today, it's Michel Beya will present Kakadu plum fruit bioactivity against spoilage microorganisms and oxidative reactions in a refrigerated raw beef patty. It's a really interesting topic, combining plant food or plant food extracts and meat. Next slide, please, Michel. I think everyone now at least met me once or know me. So I'm Michael Netzel, Senior Research Fellow from the Center for Nutrition and Food Sciences at QAFI. And I know Michel, I'm one of Michel's co-advisors, so no secret. So next slide, please, Michel. And before we start the seminar, I would like to acknowledge the traditional owners and the custodianship of the lands on which we meet today. On behalf of the traditional owners, I pay respect to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognize their valuable contributions to Australian and global society. Next one, Michelle. So the usual housekeeping, I think if you're a regular attendee of the seminars, it's in principle always the same. So the seminar is scheduled between 12 and 1. I guess Michel's presentation will go until maybe 12:40, 12:45. So we have a 50-minute Q&A session. Please, I always have to remind you, please use the Q&A button for your questions and not the chat button. So we'll address all the questions then at the end of the seminar in one session. And Michel will try to answer, all your thoughts, questions, and inquiries. And if not within the seminar, because we have to stop at or has to end at 1 p.m., I think Michel is more than happy, to answer this via email. Okay, Michel, next slide. Yeah, Michel Beya, I already mentioned this. He's a Ph.D. candidate at the Center for Nutrition and Food Sciences, and his research centers on assessing the preservative properties of selected Australian native plants in meat, or here today, meat patties. And Michel holds an advanced master's degree in food science and technology, a master's degree in animal nutrition, a graduate certificate in molecular biology, and a bachelor's degree in animal science. Furthermore, he's currently completing another certificate in policy and governance. And before he started his PhD journey with CNAFs and UQ, Michel gained over 7 years of experience in the food industry, serving as a senior quality assurance officer at the end. So Michel, please go ahead. It's all yours now.
Thank you very much, Michael, for a kind introduction. And thank you very much for everyone for joining this seminar today. As Michael said, my name is Michel. I am a terminal PhD candidate at SNAPS. So today's presentation, the topic is Kakadu plum bioactivity against spoilage microorganisms and oxidative reactions in refrigerated beef patties. I too acknowledge the traditional owners and the custodianship of the land on which we meet today and pay my respect to their ancestors and their descendants. I think Michael has pretty much introduced me. I'm just going to run through my background. Michael has said pretty much everything about myself. I do have a bachelor degree in agriculture science from the University of Washington, DR, Congo. Congo is an African country. It's a French-speaking country. I was born there and grew up there and obtained my bachelor degree in agriculture science. And then moved to South Africa. I obtained a Master of Science in Ruminant Nutrition from Stellenbosch University. Come to Australia, I obtained a graduate diploma in molecular biology from UQ, University of Queensland. And then moved on to do my master's degree advanced in food science and technology from UQ. And at the moment, I'm also doing a graduate certificate in policy and governance at QUT. and I'm expecting graduation next month. And obviously, I'm doing my PhD. I'm expecting my graduation to be next year in July. In terms of industry experience, as Michael said, before I started my PhD in 2020, I worked in the private sector in food industry for almost 7 years. First as a technical officer, and then moved on a senior position at OSI, and then GBS right in Brisbane. And GBS is the largest meat producer in the world. It's quite a big company. So I was the guy who was in charge of the food safety and quality. In terms of languages, I am fluent in 4 languages, and French is my primary language. The outline of the presentation today, I'm going to talk about a little bit the background information of the study I'm presenting today. Then I'll talk about the objectives, research questions, material and method we used, results and discussions, conclusion, and then I'll finish with the acknowledgement. This presentation of today, it comes from a paper we just published in the Meat Science. So the background information about the study, in the recent years, there has been a lot of many consumers becoming more and more cautious about the food they ingest, especially when it comes to processed food and the use of synthetic chemicals for preservation. And there's a growing concern over the long-term health effect of the use of synthetic preservatives. Synthetic preservatives have been linked to so many health issues like allergenic reactions, cardiovascular diseases, and neurodegenerative diseases, and so many other health issues. So that's a big problem as far as consumers are concerned. So that concern has put a lot of pressure on government and research institutions to look for alternative and sustainable options. And plant-derived preservatives, such as those from Kakadu plum, offer a better and sustainable alternative in addressing these concerns from the consumers, so we can be able to produce food that is healthy and good for the public. Few words about the Kakadu plum. Kakadu plum is a tiny, small green fruit. It's native to Australia, and it's located on the northern part of Australia, specifically in the north of Queensland and Western Australia. This fruit is also known by different names, such as billy goat plum, green plum, and salty plum. Kakadu plum is growing in terms of popularity. That's due to the higher level of concentration in terms of vitamin C, ascorbic acid, and strong antioxidant properties. And because of this high content in terms of bioactive compound, Kakadu plum presents itself as a serious candidate for biopreservation of food that include meat and meat products. So the objective of our study was to evaluate the antimicrobial and antioxidant activities of Kakadu plum in meat. And the research question for the study goes like this. Does Kakadu plum food have the potential to delay microbial growth and prevent lipid oxidation in raw beef patties? So we're going to answer this research question through this presentation. So when we started this project, the first step was we designed the experiment. The experimental design was the factorial design of 6 treatment by 6 sampling point by 6 repetitions. So we got the treatment here, treatment 1 to treatment 6. So we go by incremental concentration of Kakadu plum, and the sampling point was the 0 up to 20 days. So we got 0, 4, 8, 12, 16, and 20 days. So this experimental design was repeated 3 times, so 3 repetitions of 3 batch. And then at every sampling point, we collected samples and we analyzed for specific parameters that will allow us to answer to our research questions. So the parameters we analyzed include microbial growth, lipid oxidation, pH, the instrumental colors, color parameters, and surface microbial redox. So after when we designed our experiment and we took that experimental design on the production flow in a pilot plant. And the first step was we had to make samples, to make beef patties. So we got meat, we obtained meat from a company here in Brisbane. We chopped those meat in small pieces, in a small cube kind of meat, and to remove the excess, to remove the excess fat. And then we ran the meat we chopped into the first grinding through a 12-millimeter steel, as you can see the picture here. And then after we mix that minced meat with salt and polyphosphate. And then after that, we ran in the second grinding through a 8-millimeter steel plate. And then after that second grinding, we divide that mixture into 6 groups, which correspond to 6 treatments according to experimental design. Thereafter, we apply the treatment, and then we formatted the beef patties. You can see on this picture, that's where we're making the shape of the beef patties. And then we seal, because we use the map, we seal, and then the map, the oxygen was 80% of oxygen and 20% of CO2. And then after that, the samples were stored in a cold room at 4 degrees. And then at every sampling point, we're coming in and collect the samples and proceed to the analysis of different parameters as I listed them. So for all the parameters we measured, we use different techniques or methodology. For TVC, we use the pour plate method. Lipid oxidation, we use the TBARS assay. The pH, we use the direct probe insertion in the meat. And some of the picture here is there. This color, we use the chromometer. That's the instrument over here. And then the surface microbial, that was done by spectroscopy. And the bioactive compound of the Kakadu plum itself, the powder, because Kakadu plum was in powder form. So we did the identification of all the molecules using the UHPLC. And the antioxidant activity, we use the DPPH assay. After when we've run our experiment, we collect all the data. It comes the time when we had to analyze data statistically. So we use the SPSS statistical package and the GLM from that software. The treatment, the storage time, and the interaction between the treatment and the storage time were set as independent variables. And the TVC, lipid oxidation, pH, color parameters, surface microbial were set as dependent variables. And the batches, we had 3 batches, 3 repetitions, were set as random factors. The reason we put these batches as random factors was to minimize the variability between the batches. And any significant differences was identified by cookie tests, and the pH less than 0.05 was considered to be significant. And the result here, I'm going to present the major result found from our project, from our research. So here is the bioactive compound we identified in the Kakadu plum, in the powder in the Kakadu plum fruit. We use gallic acid as the standard. So we identify 11 molecules. Among these molecules, we have vitamin C, which is ascorbic acid. We have ellagic acid, we have corellagin. All these molecules have been found to possess some antimicrobial and antioxidant attribute. And they have been tested in vitro as well as in situ. In terms of antimicrobial activity, what we found that the treatment had a significant impact on microbial growth. This figure is the figure for the microbial growth. As you can see, Kakadu plum treated beef patties significantly delay microbial growth when we compare this to the negative control. The graph, the trend here, the blue one, that's a negative control. And this here, that's the Kakadu plum treated samples. And the green one, that the SMB, the sodium metabisulphite. As you can see from the graph, that the Kakadu plum treated samples, although the difference between the Kakadu plum treated samples and the negative control was marginal, but still significant. But if we compare these to the Kakadu plum treated samples and negative control compared to SMB, SMB was much more effective in preventing microbial growth. However, when it comes to the use of SMB, as I said before, that this is synthetic chemical preservatives. Consumers are worrying a lot about the use of synthetic preservatives in the food due to, in the case of SMB, due to allergenic reactions to some people. And also, one thing we observed, that the delay we observe here for Kakadu plum treated samples, we believe that could be due to the molecules or the bioactive compound we identify in the Kakadu plum powder after when we did the PLC. The result for antioxidation activity, we found that the treatment had a significant impact in terms of delaying microbial, in terms of delaying lipid oxidation. As you can see here, the lesser is the MDA, which is malondialdehyde, which is a marker for lipid oxidation, the better. As you can see, the Kakadu plum treated samples, down here, these are the Kakadu plum treated samples. And you can see the MDA is quite low. So which means that Kakadu plum was able to prevent the accumulation of MDA. MDA is a byproduct of lipid oxidation. When the oxidation occurs in product like meat, there is a rancidity, and you can smell the off flavor. So that's the consequences of when we have higher MDA in the samples. As you can see, the control, the blue one here, the control had a significant amount of MDA. And when we look at the SMB, which is the commercial preservatives the company used, although it was still lower compared to the negative control, but when we compare that trend to the Kakadu plum treated samples, we observed that Kakadu plum treated samples was much more better in preventing lipid oxidation when we compare to both the SMB and the negative control. And that's, again, we believe that this observation is due to the presence of bioactive compound in Kakadu plum. And we did the correlation analysis. We were trying to understand the relationship between the treatment and the observation we made. And we found that, as you can see, the correlation analysis, we found that 60% of the observation, which is the delaying lipid oxidation, was due to the treatment. So, which means that Kakadu plum had a significant impact in delaying microbial growth. Sorry, lipid oxidation. We also did the analysis of the relationship analysis between the treatment and some key parameters, especially when it comes to the redness, the color of the meat. We looked at the relationship between the treatment and the A's, as you can see here, the figure here. And we observed that the treatment did not have, which is the Kakadu plum inclusion into beef patties, did not have a significant impact, or I can say does not have a relationship with the variation in terms of color. As you can see, it's only about 8%, so which is quite low. So the relationship between the treatment and the change in the redness of the meat is pretty much non-existent. On the other hand, when we look at the relationship between the storage time and the redness of the meat color, we observe that about 56% of our observation, which is the change into redness, was due to the storage time. So which means that as the storage time progressed, or as the storage time advanced from 0 to 4 up to 20, and we could see the redness of the meat was diminishing, was getting reduced. So our observation concluded that the storage time had a significant impact on the redness of the meat, and this relationship was quite strong. We also looked at the relationship between TBARS, which is a lipid oxidation, and the redness of the meat. We found that lipid oxidation in our study did not have any significant relationship with the redness of the color of redness of the meat we observe. As you can see, it's only about 0.6%. So that relationship is not really existent. And when we looked at the relationship between methioglobin and the redness of the meat, we found that about 28% of the observation, which is the change in the redness of the meat, was due to lipid oxidation. So that's a moderate. We can't say it's low or it's strong. We can say that 28%, it's quite moderate. So methioglobin at some extent impacted on the redness of the meat color. So the conclusion we draw from our research, we conclude that Kakadu plum food treatment effectively inhibited lipid oxidation when compared to both commercial preservatives and the negative control. And Kakadu plum delayed microbial growth when we compare it to the negative control treatment. And Kakadu plum can be used as biopreservatives in meat and meat product. For the acknowledgement, this research was supported by ARC Center, Coffee, and I also had quite significant support from the GPS and ACC and any product where I obtained the meat and the dry ingredients we use for our experiment. Even the experiment itself was done at ACC. They were very helpful to support us in running this experiment. And I also want to thank my supervisor, Professor Lowe, Professor Yasmina, Professor Eda, and Dr. Michael. Thank you very much for your contribution to this research. Again, thank you, and back to Michael.
Thanks very much, Michel. You were really quick. I think it was the fastest seminar I ever facilitated. You know, it's just 12:25. Maybe the next slide. So any questions or anything you want to know from Michel about his study and what he presented today, the slides, just checking. So there are no questions, no Q&A. Please feel free, even if you think there are no stupid questions, you know, you can really ask whatever you think related to his topic you want to know or have any questions. Maybe wait a bit. So I have a question, Michel, and when, you know, as you know, you can have the best, you know, the healthiest food, or what you said, using natural preservative or anything, which maybe you can place some harmful chemicals or other preservatives or artificial preservatives. But at the end of the day, it's always, I will say, the appearance of the patties or the product. In your case, you know, the patties, and also, you know, sensory. I think sensory is absolutely crucial. And otherwise there won't be any, you know, consumer acceptance. Can you comment a bit on that, you know, about the sensory, this area or aspects?
Yeah, the sensory, when we ran this experiment was at the moment where we had COVID issues. That was in 2021, I think the middle of 2021. And at that time, we planned to do the sensory at that time. But unfortunately, we did not have enough trained panelists, so we were not able to run the sensory analysis for this project. So what we did, because this is part of it's one section of my thesis, so we I say sent back that section of sensory to the last chapter of my thesis. So as you can say, we've already done the sensory, and we found that the inclusion of Kakadu plum into the beef patties did not affect any sensory characteristic of the beef patties when we compared to the both negative and positive control. So the acceptability between the treated beef patties and the negative as well as the positive control was not significant. So I think that's a good thing. Any employer, anytime they use preservatives, they don't want that preservatives to impart or to change the sensory characteristic of their product. So the fact that Kakadu plum did not, for this experiment, did not impact on the sensory characteristic of the beef, I think that's it's a good sign, it's a good thing.
No, thanks, Michelle. Really, I think that's because yeah, you didn't mention this in your slide, so I think this, and you did it. I think it's absolutely crucial, and I think what you said, at the end of the day, if there is a negative impact on the sensory, on the typical what you expect from like meat patty or different products, then there won't be any really acceptance by the consumers, which at the end then is a failed product. I mean, that's really, really important, and you address this even in a, let's say, in a small scale sensory study
Yeah.
due to the circumstances, but yeah, definitely. So I think also for the others, for the audience, so that's always a really crucial issue, and often you don't think about it when you create yeah, let's say, or generate or create a novel product. You're just thinking maybe health and healthy, and to biofortify, which is great, but
Mhm.
on the other hand, you really need always think about the sensory and
Yeah.
appearance and how it looks, and taste and all these things,
Mhm.
because if it's
Yeah.
like a product, you want to sell it, you want that people you know want to eat it. So we have a couple of questions now in the Q&A. um so from Natalie, what do you think um this outcome will mean for the industry, Michelle?
Yeah, for the industry, I think that's good news. I understand that there's still a lot of work to be done, especially when it comes to the use of plant-based preservatives. And the problem is situated in the fact that, when in a food industry, when they use preservatives, they use it in a very small amount, very, very small amount. It's pretty effective. You can even look at this project for SMB, which is sodium metabisulphite, we use only 0.05%. It's a very, very tiny fraction compared to the recipe. But when it comes to the plant-based preservatives, so you need to use a little bit more, and that's with the risk that can affect, somehow the sensory properties of the product itself. But in the case of this project, I think the industry should be happy because it's a very good study, especially when we look at the strength of the strength of Kakadu plum when it comes to preventing lipid oxidation. Uh, Kakadu plum perform much better than even the SMB. So the industry should, take advantage of that, of Kakadu plum being able to prevent lipid oxidation in the product. I think it's something that should be looked at, and see how that can be improved even further than that.
Maybe then if it's a really a big demand, then maybe there's some issues with the supply chain, but it's a different area. If it's really getting accepted, as a natural preservative, then that you can really provide us supply then the demand. Okay,
Yeah.
thanks, Michel. Next question is from Ishaya. Great
Mhm.
presentation, Michel. What is the main bioactive compound in Kakadu plum?
In Kakadu plum, the main bioactive compound is vitamin C. Kakadu plum is well known mainly because of vitamin C, which is ascorbic acid. And some of the paper reported that, if you look at, we compare the standard, your orange was considered as the standard in terms of vitamin C. And some of the publication have stated that Kakadu plum has 900 times vitamin C compared to the standard, which is from orange. So it's massive. It's quite a lot in terms of the percentage of vitamin C that we have in Kakadu plum.
I think it can have, I'm very careful now, but I think it's the highest quality around 22 or 23% per tribyte. So that's a lot. That's really a
That's a
lot.
lot.
So
That's
yeah,
massive. Yeah,
and that's
yeah,
one of the quality parameters, for trading and
yeah.
also, the vitamin C content.
And even in the other industry, apart from food industry, some of the pharmaceutical industries they now using and the beauty industries they're using Kakadu plum just because of that vitamin C. Vitamin C as antioxidant. And then I've seen some of the shops around here, they use Kakadu plum in many lotions. People are use anti-aging, and just because of that, the vitamin C. So vitamin C is quite significant in Kakadu plum.
Okay, no, thanks, Michelle. Another question from Anonymous. Thanks, Dr. Michael. Sorry, just one. I'm just wondering, one of the experiment abbreviated as TVC. What is that?
STVC,
The
that's
yeah, TVC.
TVC that stands for total viable count. That's the microorganism. Total viable count.
Yeah, maybe a few more words about this, what it is, or for
Yeah,
the.
it is when you say TVC, that include any kind of microorganism. For example, for a sample in meat, uh, when you do microbial assessment, you're looking at what kind of microbes are in meat patties. So when you do, there's a specific analysis you can do specifically for detecting specific microorganisms, for example, Listeria or E. coli or Salmonella. But when you say a TVC, it means that include all the microorganisms without that include Salmonella, uh, E. coli, staph, all those microbes are under that umbrella of TVC. So TVC is the I'll say the total microorganism found on the beef patties.
Good. No, thanks, Michelle. Hope the answer was okay. If not, then just send Michelle an email, that's fine. So next question from Jessica Cartwright. Can you comment on the affordability of using Kakadu plum versus preservatives or, the chemical preservatives that are currently used? And what are the next steps for widespread use of this as a preservative?
Yeah, in terms of affordability, Kakadu plum, as far as I know, it's quite expensive. It's quite expensive if the industry has to embrace Kakadu plum as preservatives. So there's quite the cost is quite high compared to SMB, compared to uh, synthetic preservatives the industry is using right now. And then even if you look at in terms of the quantity as well, when you use Kakadu plum, you need to use quite high percentage, and that comes with cost. But when you use synthetic chemicals like SMB, it's small amount and it's cheap. So the next step for the industry, as I said before, all these studies, research, when it comes to plant-based preservatives, there's still a lot of work being done right now, and there's still a lot of work to be done just to get to the point of having plant-based preservatives to be acting with the same strength when it comes to antimicrobial and antioxidant as the same as synthetic chemicals. And again, for the cost-wise, the plant-based preservatives, in this case of Kakadu plant, is quite expensive when we compare to SMB.
Okay. Jess, if you have further questions, just ask Michel or send him an email. I think that's fine. Thanks, Michel. Now, next question from Bernadine. How long a shelf life do retailers currently achieve for patties, and does the additional of vegetables lower it?
Well, one thing I would mention on this for our experiment, if you go, for example, in a shop right now, the beef patties, first of all, the shelf life depends on the ingredients you put in the beef patties. So that has massive impact in terms of shelf life. But for our experiment, we minimize the amount of ingredients we're going to use. So we use only salt and polyphosphate, only these two ingredients. So we didn't want to use any other ingredients not to interfere with our study. But in a normal situation, like in a shop, in beef patties, what the shelf life is around 16-20 days. And it also depends on the storage conditions as well, because that has massive impact. If, for example, you store your beef patty at 4 degrees, so you can get up to 16-20 days. But some of the beef patties are frozen. When you froze beef patties, then definitely the shelf life will be much more longer. So there's so many factors that can have an impact on the shelf life.
So you can, or you didn't do a direct comparison. What I think what Bernadine means, if you have the same storage conditions and then you just replace with like Kakadu plum or a vegetable extract, if this really lower the shelf life, or if not within this standard storage time or shelf life, so you didn't do a direct comparison, no?
No, actually we did not. You asking whether we did the comparison between this experiment with the
I'm thinking
commercial
under the
beef
same,
patties.
exactly the same. If you have identical storage conditions, and then you say, look, I replace the standard ones with like Kakadu plum, if this will lower, or maybe not, or just insignificant or something happened.
If I understand the question properly, is you're asking whether if the experiment we ran, this experiment we compare to the commercial beef patties from the shop, what the difference in terms of shelf life? Is that the question?
No, I think she mentioned how long a shelf life do retailers currently achieve for patties,
okay.
and does the additional of vegetables lower it? Oh, sir. Okay, Bernadine just clarified. Sorry, Michel. Sorry if that wasn't clear. I just wondered what was the industry norm.
Well, the industry norm, as far as I know, the shelf life is around 16-20 days of shelf life for beef patties.
Okay, and we can achieve.
Yeah.
Okay, no, thanks.
And
thanks,
also, I need to mention
Bernadine.
that's the standard. But again, as I said before, the shelf life depends a lot on the storage conditions. For example, in our experiment, we use the MAP. Some of MAP, we use 80% oxygen and 20% CO2. So in a case where you use, for example, vacuum, some of the beef patty, they use the vacuum packaging. And some of them, they just don't use any MAP. They don't vacuum them. They just package them and then they just seal them. So that also will have quite an impact on the shelf life.
Mm-hmm.
So there's no like a set standard in terms of shelf life, but everything depends on so many other factors.
Okay.
And also the initial microbial load of the meat itself. If you start your beef patty start with a high microbial load, definitely the shelf life will be much more shorter. But if the meat you started with initially has a lower microbial load, then your shelf life is likely to be more longer than when its microbial load is high.
I mean, you made the same experience, Michel, you know, when you had this, I would say, with
Yeah,
lower quality meat at the beginning with this high count and a very,
exactly.
very short shelf life. So
Yeah,
this was really, really very interesting
yeah,
and frustrating at the
yeah.
beginning. And
That's
then
right.
because you couldn't get the highest or the best quality, and
Yeah,
then, you know, the shelf life was really, really short because it
yeah.
was
It was
already this high count at the beginning. Sorry,
At the
Michel.
beginning.
Yeah,
Yeah,
yeah.
at the beginning, as Michael said, the trial we did at the beginning of the study, we used collect meat from the shop. And from the start already, the microbial load was quite high. And we end up having a shelf life of 4 days, or 4 days, all the beef patties off. And it was quite high. So I found myself in a situation where it was not possible for me to run the experiment. So what I did is I had to talk to the companies, GBS and also ACC, to obtain the meat that is really, really very low microbial load. And so that makes a massive difference in terms of how long the shelf life can be.
Thanks, Michel. So next question from Guy from South Africa. Price is very important in development of new product. What is the cost making this product compared to the one used currently?
Well, we didn't really research on the cost, unfortunately, but I'm happy to do an investigation on this and provide with more information about that.
What would you say, Michel? Can you maybe very, very rough would be maybe more expensive or a little bit, or I mean, you think about the supply, or you can't make any comments
Well,
yet?
definitely I can't make any call. I'm really I didn't
Okay.
look on the cost side of
No, it's
this,
fine. Yeah,
but
yeah, yeah. But you know, that depends also then, you know, how you got all the you know, the supply and the Kakadu plum and the quality and the price, and that's always a bit of a black box, you know, which then you have to calculate at the end. But it's a really good question, very important as well, you know, like the price, if consumers are happy to pay a premium for say for let's say, you know, it's maybe more healthy, or you know, you have these natural preservatives, on how much they willing to pay more, or if it's the same price, maybe then it's maybe not a big question. So last question from Madeline. In the article, the pH is also reported to be lowered by the Kakadu plum treatment. Lower pH also reduces lipid oxidation. How much of the observed reduction in the lipid oxidation do you think is due to the bioactive components versus the lowered pH in the samples? That's a very good question. It's a long one. Okay, so let me repeat. Okay, in your article, Michel, you presented the pH is also reported, you showed, lowered by the Kakadu plum treatment.
That's right.
Correct. Yeah. Lower pH also reduces lipid oxidation. Yep. And what do you think? How much of the observed reduction in your lipid oxidation is based or is caused by the bioactive compounds or by the pH, by the lowered pH?
Yeah. Lower pH. Yeah.
That is a good question. Really good. Yeah.
I think I believe I believe that most of the observation we made in this paper, the bioactive compound played a big impact in terms of oxidation. But as far as the lower pH is concerned, there's a lot of paper out there. There's no established agreement whether pH can prevent lipid oxidation. Some of the paper, they say that lower pH, it even speed up lipid oxidation. Some other authors, they argue, they say, well, lower pH prevent lipid oxidation. So there's no an established agreement. But as far as this our paper is concerned, I believe bioactive compound from Kakadu plum played a big role in preventing lipid oxidation.
But it's a good question, no, and I think
Yeah, it's
it would be
that's a good
a
question.
very
Yeah.
interesting additional or maybe extra experiment. And Madeleine,
Yeah.
that's right, to see if or if not. And what Michel said, even in the literature, it's a bit controversy still.
Yeah.
But to see if just lowering the pH, what kind of effect, especially in your experiment, like in the beef patties, or I mean, the bioactives in Kakadu plum are well known because they're really very strong antioxidants. Also, you have some, a broad range of phenolic compounds, and they all usually act in a specific range, concentration range, as antioxidants, which for sure are in food systems can prevent an oxidation. But I think that's a really good question for maybe another experiment. Not for you, Michel.
Yeah.
No, I think there are no more questions in the chat, and I think we had really a very long Q&A session. Thanks very much, for all your questions and interest. And again, when you have some additional question, want to know something, just send Michel an email. I think, Michel, you can maybe the next slide. So yeah, in 2 weeks' time, we have, I think, not sure if it's the last GWAFI seminar for this year, at the 5th of December. Dr. Sukita Srivarathan will present her research about Australian indigenous edible halophytes, potential sources of functional ingredients, a very, very interesting topic. She's also from the Center for Nutrition and Food Sciences. And hopefully you have again time for zooming in. I know it's always challenging from 12 to 1 and lunchtime, and at the end of the year, all the seminars, and it's still full on, but hopefully you can make it, would be great. And if you just check out the website, the seminar website, for more information, and hopefully you enjoyed the seminar today. If you are new, so you can always sign up for the seminar invitation list at gwafi.uq.edu.au/science-seminars, or just check out the website. Or if you have any specific questions, you can send Greg Harner an email. So he's the overall host of the seminar, or Megan Pop, or myself, doesn't matter. And yeah, again, thank you very much for zooming in today and your time, and hopefully see you then in 2 weeks. Thanks. Bye.